Okay, so this talk will be mostly about CloudStack, Ceph integration into CloudStack, how it works, a couple of things how you can do certain checks on the Ceph level based on information from CloudStack, how to fiddle around with images and so on, and a couple of specifics around snapshots and how they're implemented, basically. I was going to cover some basic theory, but I understand there is a probably 10 times better presentation from IBM going on after me or sometime after me, so I won't be spending too much time there. Now, a short quiz for, most of you or all of you are actually some kind of a Ceph users. Do you have, okay, let me just see if I can go to another slide. Yeah, actually, that's for the next one. Anyway, a couple of words about me. I'm working as a cloud architect at ShapeBlue for the last this is 7th year or so. And yeah, I've been involved with CloudStack from the early days, not necessarily some other people probably, but yeah, decently. Early on, I'm also project committer, PMC member as well, and yeah, I have a couple of preferences in my life with full understanding for different opinions. So that's it. Now, short question. Even though the whole thing I'm working on, I'll be presenting it, is not actually related to a specific Ceph release. Question for all of you Ceph guys, which Ceph release am I going to kind of use or talk about based on the image you see? But it's an important one, it's based on that image. Anybody? Yeah, actually that was a funny one. If you guys are, this is a quote from the official documentation. So yeah, it's Squidward, character from the SpongeBob. Anyway, right. So I won't be spending time, obviously, explaining what Ceph is and how it works in any level of details. But it has evolved over years into I would say a beast in comparison to where it was maybe 6-7 years ago when I was actually running it in production before I joined ShapeBlue. It's basically at the bottom we have a Rados cluster, and then obviously we have different libraries and different ways of accessing different, accessing Ceph cluster in different ways via S3 clients, via RBD, basically passing through images, in our case to Cemu, or mounting it locally, whatever you like to do. And of course, Ceph file system, which I see that in the recent releases there, it's been out there, is a support for Windows as well to consume Ceph file system, which is really great. Basically, we have a couple of daemons, again, which are mandatory, like OSDs, which are the object storage daemons. We have a couple of monitors, optionally metadata servers if you're running CephFS. But yeah, I guess for the sake of POC, if you want to try to do something, you can even install it on a single host, even though there are some caveats. But yeah, I would say 2 hosts are kind of okay for literally demonstration of how it works. You'll have to have at least 3 monitors in production, up to 5. And actually, I'm going to actually leave this for a bit later. Again, won't be spending too much time. This is all kind of a pure Ceph basics, if you like. You'll notice we have just a couple of monitors. I think like 3 monitors over there. Yeah, and a bunch of OSDs, obviously, which is what serves the data to the customers. Now, I'm making a joke here in the most positive way. A long time ago, you had to install Ceph in different ways. Obviously, a lot of manual things. Now, in obviously the last couple of releases, and actually more than just a couple of releases, the deployment methods have evolved. You have Ceph Ansible, you have Rook, and everything else. But we have what's at the moment, well, at least in the documentation, kind of recommended for a smaller deployment. It's using Ceph ADM or Ceph admin, if you like, tool. Now, I'm making a joke. This is Skynet mode because, well, because you'll see a bit later on, it's doing things on its own, really. And I'll explain what I mean by that. So yeah, before we just dive into a brief POC installation, you need to synchronize your time. F2DN should be there, and certain software prerequisites they're all installed by default. And yeah, we'll use Ceph ADM tool to actually to actually deploy our cluster. We're adding the repository. There are other ways to add the repository as well of a specific release, which is Quincy. We're installing Ceph ADM on the first node, or you can have an admin node if you like. Then we're basically bootstrapping a cluster by defining the first the IP of the first monitor, which should be the node itself. And actually, it does awful lot of work for you. It will obviously create monitor and manager daemons. It will generate the specific SSH private and public key. Also inject the public part of the key into the local node's authorized file, which later we will use to inject on other nodes as well. Create admin keyrings and do all kind of stuff, really configure the dashboard for you and so on and so forth. At least the initial things, and of course you can always change. After this single bootstrap command, basically we have our cluster up and running. It will be in some kind of a warning status, and obviously just a single monitor daemon, nothing else. Monitor and manager daemons running on the first node, nothing else really. These days everything is done in containers, so basically all of these services, if you like, both monitor and these services, they work within either Docker or Podman. So that's, let's say, a couple of things that has been changed over the years. But either way, once we have the initial cluster bootstrap on single node, we will just copy basically the SSH key to other. Try to control my mouse. To other two nodes, just injecting the public key in the authorized files, and then finally we'll be adding those two hosts optionally with the label admin. As you can see, because when you put the label admin, it will actually ensure there is a copy of the ceph.conf and the client admin key on those nodes, so you can use extra administration tools like Ceph or RBD or whatever you actually install there. Now, instead of actually, let me go there a bit later. What this does is it only adds the host into the cluster. However, a few minutes later, you will actually have monitors deployed on all those free hosts in our example of the POC. And also there will be a total of 2 managers running, one active, one standby. If you actually go ahead and check the documentation, you will actually see that Ceph spins automatically unless you configure it differently before creating monitors. There are ways to do it differently, but it will automatically spin minimum of 3 up to 5 monitors on arbitrary nodes. If there is a load increase, there will be 5 nodes. If there is a load decrease, there is no need for additional monitors. It will simply recycle monitors and bring them up and down on its own. Which again, there should be at least a placement control out of 300 nodes or whatever. You might want to only be running monitor on 3 specific nodes or 5 or so on, and then let Ceph do its magic, or you can manually install it. After this, basically, after the previous steps, we can actually see we have 3 monitors running, and we have 2 managers running. Obviously, no SDs as of yet. But yeah, again, as I mentioned, there is no need to manually add additional monitors, even though it might be actually preferred by all means in a production environment. There is no need to configure the dashboard, SSL, self-signed certificate, and so on. Everything is done for you during the bootstrap as well, so you get your dashboard password. So it's really, for the pure POC mode, this is insanely simple. It's literally what you see on the screen. Those are all the steps needed. Now, finally, we are adding the DevSDB device, which is a second disk from the 3 nodes. And after a couple of minutes, literally, you would have your all 3 OSDs up and running. So you have a full working cluster. Obviously, this is pure POC. You won't be doing things this easy and without really thinking about it, like I did right here. But yeah, that's basically it. We have a running Ceph cluster. Now we want to create a pool, which is called CloudStack. We need to do the RBD pool init, which is basically marking this pool to be used for RBD kind of things. And finally, we want to create authentication key or username, if you like, and a secret key, so that we can pass this to CloudStack when we add this specific primary pool, as a primary storage in CloudStack. So yeah, dashboard, which I'm not going to really spend too much time on, has evolved over the last years to really support doing most of the things, obviously, except some crazy advanced stuff. This is based on the Quincy, which I later upgraded with a single command to a 17, 18.2, which is Riff release, including dashboard. Everything is completely automated, which is nice indeed, but yeah, you need to, I guess, understand what's going on behind. You can do various things, obviously manage basic cluster settings, you manage OSDs, you can manage pools, you can now so much more control before the previous releases where there was a basically, create pool, delete pool, for example. Now you can do other things as well. Awful lot of improvements. I'm not going to go through these. This presentation is not meant to be obviously about Ceph release notes and stuff like that, but just to basically give you an idea of how much it has evolved over the last couple of years. The dashboard specifically, what I'm mentioning over here, Ceph, leave Ceph alone, obviously. Once we have this ready, now I was basically supposed to do a short demo, and then I basically thought there is no actual content for the demo besides showing you what you probably will be seeing a little bit better on your screens. We literally just need to, when we create a primary storage for a cluster, or it can be zone-wide, we basically need to define monitors, and now with CloudStack 4.18.0, I think, we've added support for multiple monitors, so you don't need to use the round-robin DNS as you previously would like to use to avoid when a single monitor goes down that or your connections are down and so on and so forth. So you can specify, obviously, 3 comma-separated multiple monitors, no really hard-coded upper limit that I'm aware of. We're specifying the Rados pool, the user that we created, and the password. For these purposes, I'm also setting a storage tag so that I can basically force the new volumes that are created to go to the specifically Ceph pool. Now, once this is done, you would go and you would add a compute offering. Now I'm trying to zoom in, hopefully, so that it makes a little bit more sense. Whatever is the compute offering specifications, effectively, when deploying from template, the only important thing to mention is that I've actually added here the RBD storage flag. So basically, whenever you create a VM using this compute offering, CloudStack will search for a storage pool that has the storage tag RBD, which is only on the Ceph, and that's pretty much it. After that, you would open a new VM deployment form and just reference whatever is the compute offering you previously created. Similarly goes for the data disk offering, just create a data disk offering of whatever specific custom size, fixed size, whatever, and specify the storage pool RBD to ensure it's created on the Ceph. Now, that's basically it. Now, in order to ensure that this, basically adding Ceph as a primary storage pool works, it needs to be successful across all KVM nodes in the cluster or zone, which means that you should have appropriate versions of the librd and librados. So make sure that on KVM nodes, which are maybe not parts of the cluster, to install them from the corresponding repo. So we are talking about Quincy here. The stock libraries are, I think, from at least on EL9. I think I use Oracle Enterprise Linux 9. The stock libraries for the librd are version 15 dot something. And that will basically be a problem. So I just need to add a specific Quincy repo, YAM update, if you like, librd, and that's it. A couple of dependencies are upgraded, so your client is of the same version. And that's pretty much it. What you need to do on KVM host to enable them to successfully connect, and then this works really without any problems. Right, so finding your way around, basically, from time to time, you might need to obviously troubleshoot things. We heard today a very, let's say, complex troubleshooting path or a session from one of the colleagues from the Ceph community. So basically, if you go into a UI and you observe the ID, of the volume, Assuming this is a new virtual machine, new volume, which was created, not migrated from another platform, then there would be RBD image with the same value. The name of the image, if you like, is based on the UID from CloudStack. To be more specific, this is the path here from the database. If you are not migrating volumes, this is the rule basically that you'll know. Now, if you put RBD info just to show information about this specific image, you'll see it's 8 gigs in size. And it's actually a child image of the parent image, which is actually our template. You'll see later on. So we have a template. I'll explain the next steps. On the next slide, actually, I'll explain the steps, how this works. So it's a child image of the base snapshot, just a snapshot with a funny name, base, of the template which was previously moved by CloudStack. But let's see this in more steps, actually, with more readable step. So when we wanted to actually, in my example that I'm showing you, I deployed a VM from a new template. This template in the CloudStack database would have this specific ID, DAA, and so on. So basically, CloudStack would copy this using Camo image utility from the CNFS secondary storage into Ceph and RBD image. Then it would create a snapshot, which is just called base snapshot, but it's purely a snapshot. And it's getting protected so that you cannot accidentally delete it. And then later we create, for each of the root volumes of all the VMs from that snapshot, we create a child of this clone of the template. Well, sorry, not clone, the child of the base snapshot, if you like. Now, if you want, you can also list, for example, all the children of a specific snapshot of a template image file. In my case, there is only a single one because I deployed a single VM, but if you deploy 100 VMs from a same template, you would here see basically all the children images which are related to this one. Right. If you would like to basically manually reproduce what I just kind of explained, the commands roughly, obviously with those arbitrary names, would be to create your template by first importing it, maybe not really creating, obviously you would like to probably import using Camo image or RBD import or whatever. Then you would create, the second step is to create a base snapshot. You would protect the snapshot and you would create a clone, which actually creates kind of a child image from this template, from this snapshot of the template. That's basically what the CloudStack does when you just deploy a first VM for a brand new template. The opposite steps are basically at some point would be to just delete the volume. That's fine. If you have no VMs deployed from a certain template, CloudStack will try to do a garbage collection to remove basically a template from the primary storage, and then it will basically unprotect the snapshot when it has no children, delete the snapshot, delete the template, and that's it. Or if you actually go and delete the template yourself, assuming there are no running VMs from the template, that's basically what's really going on. Now, next slide with a wrong title, my apologies. This is a word hacking, but basically playing around, assuming there is no encryption, which hopefully you should be having these days. You are able actually to go and map the RBD image, any RBD image from Ceph, either via kernel client, which happens to work fine in EL, well, actually OL 9, or you can use RBD NBD basically to talk to the librd and still map it as a local device. It will appear as /dev/RBD0, or if you are using the NBD, RBD NBD, it will be dev NBD0, and it just will appear as a local device. So you can actually check it, mount the partitions, assuming it's Linux, maybe even Windows. Obviously, there is some support, at least for the read-only stuff. So you can actually go inside the volume, which is something that your customers probably won't be happy if you do. But yeah, I'm just saying the possibilities and how it works. If you want to check information from the Camo side, you can always use the Camo image. Now, if you do not have, and you don't really need to have the ceph.conf and the admin keyring or the CloudStack keyring in the /etc/ceph folder on the KVM nodes, if you had this, then you would just be able to say Camo image info, and it will look for the specific cluster and authentication won't ask for this one, but how it works in CloudStack, we don't rely on that. It's the last line where basically, okay, we send the command that we want, which is camera image info, but later on, we need to specify what are the monitor IPs, what's the authentication method, let's say the username or the key and the secret or that. That's basically how we work with CloudStack. Even if we convert the image, that's how we do. We convert from a QCOW2 or NFS into a RBD image on Ceph. That's where we deploy a brand new VM from our first VM from a brand new template. Now a bit of words, but nothing special, I guess, around snapshots in CloudStack. When you do a volume snapshot in CloudStack, what happens is that actually the RBD image snapshot will be created, which is obviously internal, which is internal RBD snapshot, and then by default we also use, which is the third line. You can see the camera image convert command. That's basically the command with a bit of more authentication strings, which I removed for readability. This is basically what happens. We then copy or export this snapshot, which is just a data in a point in time. We export it to a secondary storage by default. Now, if you that's a second step, but the internal snapshot stays there all the time. You can skip backing up those if you're using Ceph, because there is no, you can argue there is no benefit to actually copying this to a secondary storage in case of Ceph specifically, because we always keep the snapshots on the RBD images. And if you configure the specific global setting, snapshot backup to secondary to false, then CloudStack will not initiate this step number 2. It just creates internal RBD snapshot. This is interesting because you save some space, and assuming it's a distributed system, obviously, you don't need to worry really about losing your data that much. So yeah, I'm not sure that you actually want to export to NFS or secondary storage at all. When we restore the volume, there is now, in the last couple of releases, obviously there is possibility to restore a volume. What it will do, it will actually look for the specific snapshot by the ID and this and that on the specific RBD image, simply trigger restoring, let's say, the snapshot on the RBD image level, and it's very quick. Very quick, depends on the number of changes you've been doing from the time of the last snapshot was done. But yeah, it's kind of it happens on the primary storage. There is no QCOW2 copied back from secondary storage to primary, and no overwrites happening, which is how it works with some different storage platforms. So this is actually a nice thing to do. Related to possible limitations, nothing to do with Ceph really. Whenever you pass through some roadblock devices, either Ceph or iSCSI or whatever, fiber channel or something else, there is no QCOW2 file, so there is nowhere to place the metadata of the VM snapshot, and that's something that yeah, we wish would be possible, but unfortunately it's purely KVM limitation. As part of the CloudStack, I think we still don't support the storage firebit file, if I'm not mistaken, and that's basically it. All the other normal VM lifecycle operations would work. So it's been there for a long time, and yeah, that's basically it. Now I won't be obviously now lecturing about things. This is just me ranting about my learning curve a lot of years ago, and to be honest, I'm not an active Ceph user anymore. But yeah, it takes some time to actually understand what you're doing, because what I did with a Skynet mode installation, as I called it, is ridiculous, obviously, in sense of you know, if your monitors are moving left and right, you need to actually kind of reference some static monitor IPs in your CloudStack cluster and so on. So there is a lot of things to do actually manually in a proper production environment. And yeah, just because it's possible doesn't really mean you should be using it all the way. It is really self-healing, self-managing, self-whatever, but sometimes you'll have to, you know, dig up basically, or how to say this in English, your things and actually do a little bit of surgery. Performance considerations, this is kind of all data that's already brought from the time of Nautilus, but with a couple of last releases, it's actually not NVMEs or anything else, and low latencies, as Guido already explained. This will basically ensure very decent IO pattern considering it's a distributed storage system, you cannot obviously expect the same latencies as if you were using a local NVMe device, because every write needs to be sent to 2 or 3, in production usually 3 OSD copies, acknowledged, and then only the let's say IO finishes really, or the client will get the confirmation acknowledgement that it's done. So that's basically it. And yeah, I once managed, don't ask me who told me to use consumer SSDs to get like, I don't know, like 10 Samsung consumer SSDs dead because of using it in Ceph cluster in 7 days. So don't do that. Right, so a lot of improvements, as I already mentioned, and it's become a real beast. That's basically it. So I'm myself really kind of, I would say actually impressed. But yeah, a complex system and interesting system to handle. That would be it from my side. So if you guys have any questions, I'm happy to answer.